Okay, so let's refresh this page. This is your kind of plan for the week. We are in, it's kind of crazy to think, but we are in week 7 of the online learning or distance learning. Today we're going to go, oh, that's the wrong, hang on, that's the wrong class. There we go. All right, today we're going to finish the notes for 10.6, which is circles and area and arcs, arc length. And then we're going to start 10.7, which is area of circles. And then we'll finish that on Wednesday. So tonight's homework is going to be the 10.6 part 2, which is just the arc length. And then 10.7 part 1, which is just area of circle. We're going to finish on Wednesday. We'll talk about a quiz review on Wednesday. And then on Friday, I'll assign the quiz. So it probably won't be, we might be able to start it in between. But it will probably be like almost like a take-home quiz where you'll do it over the weekend because we went Friday's way too short to be able to slam that in. And that will be your last quiz of the quarter. So just a quick refresher, what we talked about last week. Obviously, we did circles. We worked through the definition of the circles and some of the vocab, what's the radii, what's the central angle, what's the diameter and the center, all that. We talked about how to classify arc lengths as either a semicircle, which is half a circle, a minor arc, which is less than half or less than 180, and a major arc, which is bigger than 180. So that's classifying them as their types. We work through these examples where we named the minor arcs, the major arcs, and the semicircles. Here's the measure of it. We said something like this. So if I wanted to know the measure of arc RT, it would be equal to the angle that forms it, which would be 50 degrees. If we wanted to find the large arc, like arc R, QT, it's everything but that 50 degrees, so we would do 360 minus 50 and get 310. So this is all part of what we talked about it actually was last Wednesday. We got into arcs and the angle addition, the arc addition postulate, which means if I had two arcs side by side, I can add them together to find the measure of the arc, just like the angle addition and the arc, just like the segment addition and the angle addition. And then we worked through example 3 or 2 where we were finding the measure of those arcs. Okay, so circumference of a circle is 2 pi r or pi d. This is where we left off last week, which is slide, where are we on 8, okay? So this is circumference of a circle, something that you've been covering since elementary school, but it is something that we're gonna apply to, in a moment, the arc length. So you need to know how to find the circumference. Circumference is the measurement all the way around the circle. So if you had like a pizza and you measured the length of the crust, okay? If you had a frisbee and you want to know circumference, you would actually have to take a string and wrap it all the way around the circle and then lay that against a ruler, and that's how you would find the length around all the way, or the circumference is the length all the way around the circle. So it's the same thing as perimeter, okay? There's no such thing as perimeter of a circle. It is instead called the circumference. And again, you can either use pi d, which is pi times diameter, or you can use 2 pi r because 2 times r is the same thing as diameter. So here's what those questions will look like. Find the circumference of the given circle and leave your answers in terms of pi. So there's going to be a couple different ways you're going to see answers to these. Some will tell you to use pi as 3.14. Some will tell you to use the pi button on your calculator. Or like this one where it actually just says leave it in terms of pi, which means pi is going to be part of your answer. So if we look at A, remember you have two options. Circumference is either 2 pi r or circumference is pi d. If you're given diameter, you want to use the second one. If you're given the radius, like in this case, this is the radius, then I'm going to use the first one. So I'm going to say circumference equals 2 times pi times 5. And because multiplication can be done in any order, I can rearrange these in any order I want. I can put the two numbers next to each other and push the pi to the end, multiply that out, and I get circumference is 10 pi. It's a length, so it would be in centimeters, not centimeters squared or anything like that. It would stay the way that it is. So if it had said use 3.14 as pi, then I would have multiplied 10 times 3.14. You would have gotten 31.4. If it had said use your calculator and round it, then you would do that. But this specifically said leave it in terms of pi, which means the pi is part of your answer. Questions on that one? All right, B, when that length is in the middle like that, it's saying that this is diameter. So for this, I just want to use pi times diameter. C would equal pi times 18, and then I just write it as 18 pi. It would be inches. That's my answer. So I don't even have to multiply those out. It didn't say use 3.14. If it had said use 3.14, you would literally do 18 times 3.14. which would be 56.52. Or if it said use the pi button on your calculator, you'd get 56.54866, and you'd round that to some sort of decimal place, whatever it tells you. But again, this question said leave it in terms of pi, which is why my answer stays 18 pi. Easy stuff, right? Questions? So again, the arc length would be like the length of this arc here, right? Which is going to be in a linear unit like inches or centimeters or anything like that. I'm going to do the measure of that arc, which would be the same as the measure of this angle. So if this was 50, then I would say 50 over 360 equals 2 pi r, or pi times d, and you'll get given a measurement for r or for the diameter. All right, so example 4 says find the length of the red arc and leave your answers in terms of pi. So I'm going to zoom in on A. I know that the formula for the arc length is the measure of the arc. So this would be arc xy over 360 times either pi d or 2 pi r. This time they give us the whole thing here, so this is the diameter, so I'm going to use pi times diameter. So if I want to know the length of this arc, I have to know its measure. This right angle thing here tells me this is 90 degrees, which means this would also be 90 degrees. So it'd be 90 over 360 times pi times the diameter, which is 16. Now, if you want to keep this in fraction form, all of this would be over 1, because it's going to say leave your answers in terms of pi. So we're not just typing that into the calculator. We need to simplify it the way it is. So I can cross through the zeros on 90 and 360. 9 goes into itself, 1 and into 36 4 times. So this is now 1/4 times pi over 1 times 16 over 1. Remember, we can arrange this in any way we want. So if I want to push the pi to the end, this becomes 1/4 times 16 over 1 times pi. And then 4 goes into 16 4 times. Multiply out the numerators and you get 4 pi. The denominators are just 1. So this would be 4 pi inches. Questions on that one? Okay, B. The measure of the arc we're looking for is this big arc here. This time they gave me 15. That's on the radius. So that's the radius, which means I'm going to use the measure of arc xpy over 360 times 2 pi r, which is 15. I'm going to put all this over 1 so I know those are all numerators. And I'm going to sub in the measure of this arc, which is right there on it, 240. So 240 over 360 times, I'm going to push the pi to the end, times 2 over 1, 15 over 1, and then pi over 1 all the way to the end. These both have zeros in them, so again I can cross through those zeros. 24 and 36 are both divisible by 12. So this would be 2 and this would be 3. And now I'm at 2/3 times 2 over 1 times 15 over 1 times pi. 3 goes into 15 5 times. And now I would multiply 2 times 2, that's 4, times 5, that's 20. Pi is still there, and there's nothing but 1s left in my denominator. So it's going to stay like that. So 10-7 is areas of circles and sectors. So we're just going to do the areas today. Again, that should be the review part. So 10-6 goes circumference and arc length. 10-7 goes areas of a circle and then area of a sector. So those kind of go together. So let's review area of a circle. Obviously something, again, that we've been learning for a long time. In your book, it's called Theorem 1011. The name is not important because the formula is what's important, right? We need to know, so we can ignore that part and just know this. The area of a circle is pi r squared. So this time there's no options. It's not like you can use diameter or you can use radius. You only have the radius to use. If they give you the diameter, you're going to have to cut it in half. So if instead of giving you the radius, they give you the diameter, you're going to start by dividing that by 2 or cutting it in half. And then you're going to plug it in. So because it's area, all of these units are going to be squared. If it's centimeters, it's centimeters squared. Inches, inches squared, that kind of stuff. So arc length is not squared. Area is. Circumference, not squared. Area is. Alright, so here's example 1. Find the area of the circle with a radius of 10 centimeters and leave your answer in terms of pi. So area equals pi r squared. If my radius is 10, I just have to plug that in. 10 squared. 10 times 10 is 100. And then we keep the pi at the end. So area would equal 100 pi. You're going to leave pi as it is. Centimeters is my units, so centimeters squared. If it had said use pi as 3.14, it would look like this. Then you would do 100 times 3.14, which would be 314. If it said use pi in the calculator, then in the calculator you can do 100 times pi on the calculator. And then it will tell you what to round to. So it would be 314.15926 and so on and so forth. And it will tell you either round to the nearest 10th or round to the nearest 100th. Just pay attention to your directions. If it says keep in terms of pi, you don't even have to use the pi button. Example 2 says this. What's the area of a circular ice skating rink with a diameter of 48 feet? So first of all, it's area, right? You want to identify that because it's going to start to change, right? Sometimes it's going to be area, sometimes it's going to be circumference. You got to be really careful, make sure you're picking out the right words. That's area, which means that it is pi r squared. And then the second piece of information it gives me is that the diameter is 48 feet, or the whole thing all the way across. So in a circumference, I can use that as part of the equation, but for area, you want to make it become radius. So if the diameter is 48, then the radius is 48 divided by 2, or 24. So I get area equals pi times 24 squared. Without a calculator, obviously, you've got to multiply that out. So 24 times 24 would be 16, 9, 8, 4, 576 pi. This time it doesn't say what to round to. So I'm going to say let's use pi on the calculator and then round to 2 decimal places, because that's probably how it would be on a standardized test. I'll keep it in terms of pi, so your answer would have been this probably on your quiz and your test. I'll keep it in terms of pi, but on a standardized test, they'll usually use pi, so it's a good thing to get to practice it. 756 times pi gives me 1809.557, so if I'm to round that to 2 decimal places, that rounds to 56, and this would be feet squared. So no matter if that quiz is like a take-home quiz or a quiz that we can actually fit into time on Friday, you'll still have a calculator. So don't stress too much about the multiplication, that 24 times 24, if that hangs you up. I mean, obviously that's something you should be able to do. And if you were in class, you wouldn't have a calculator for it. So that's another Corona perk. But you will have access to a calculator when you take this quiz or your test. So you can always use that to fall back on checking your work on your multiplication. Questions so far? All right, so keep in mind, as far as quiz goes, we did in 10.6 the measure of the arc, the classification of the arc, and then the circumference and arc length. And then this one we just did the area of the whole circle. And then on Wednesday we're going to do notes on how to find area of just like a single piece of the pie, so a sector of the circle. And that's what your quiz will be on Friday. So if you will go to Canvas and grab the homework that's there for today, it has both 11, oh actually I sent it to myself. It has both 11.6 part 2 and 11.7 part 1. So it looks like this, if you'll get that open. It looks like this. And I'll give you got about 15 minutes left in class, so I'll give you that time to work on it. If you've got a question, just let me know while you're working. And then when we get closer to that 11:30 mark, I'll let you know when you can put your cameras back on so that you can get dismissed. So again,